Welcome, everybody. I am Maria Fossati, and I will present you the paper From Robots to Humans, Prosthetic for All by Fossati, Catalano, Grioli, and Professor Antonio Bicchi. I would like to introduce this work with a clip from the documentary Leonardo Cinquecento, shooted also at Centro Piaggio by Magnitudo Film, where Cacciari and Professor Bicchi underline the importance of the end as a part of human intelligence itself. The end intended as a thinking tool able to build itself the human thinking models. Traditionally, in history, prostheses have been designed to replace specific functional abilities. For example, to offer amputees the possibility to grasp objects and recovery and functionalities. But in these simple videos are evident other aspects. How the hand is also a medium that permits self and social interactions. For example, on the left, the Soft and Pro allow me to do little jokes, and on the right, it let me teach an engineer to dance. Simple gestures that overcome the idea of the prosthesis as a functional tool and conceal a sophisticated technology. The Soft Hand Pro comes directly from the industrial soft hand. That is a simple, robust, and effective robot hand, which combines the modern technology of soft robotics with a bio-inspired joint design. It uses the neuromorphic principle of sensory-motor synergies and is able to achieve an adaptable and gentle grasp, together with advanced manipulation capabilities. Originally, it was developed for the industry by the Italian Institute of Technology and the Piaggio Research Center of the University of Pisa. Currently, this hand is becoming a prosthesis, the Soft Hand Pro, thanks to the Horizon 2020 research projects. 30 prosthetic users are currently testing the hand in 4 academic and rehabilitation centers around the world to improve design and dexterity. The Soft Hand Pro is integrated with conventional controllers for prosthesis, 1 or 2 EMG sensors. This traditional solution perfectly fit the Pisa IIT Soft Hand system with its 2 input requirements, the opening and the closing commands. Here is possible to see some pictures about the research activities. The Soft Hand Pro has 19 degrees of freedom as the human hand, but the use of only one motor keeps the hand very light and robust. Moreover, it has elastic fingers to interact with the environment, and this tendon-based transmission system lets the fingers to adapt to different shapes. The hand so designed has a complete interdependence between the phalanxes, in line with the concept of human hand synergies. Plus, it has a passive mobile wrist that amplify this idea of softness, that make the hand unique in terms of self-interaction, social interaction, grasp possibilities, and environmental interaction. As it's possible to see on the left, the Soft Hand Pro is very robust. On the right, we can see that the hand has also a very good lift force, up to 20 kilos. One of the key issues deepened in this paper is related to the possible positioning of the Soft Hand Pro on the market. Concerning this aspect, one of the emerging strengths of the hand is its economic sustainability, due to the relative simplicity of its electromechanical architecture. Touching a framework, few robotic hands are available worldwide and are owned mostly by few leader companies. Michelangelo has 2 motors plus rigid fingers. It offers 7 grip types. The bionic hand has an individual motor for each rigid finger. It has up to 14 programmable grip patterns. MyoHand is the oldest hand in the Ottobock fleet, originally designed in the 60s. It has a 3-digital rigid grasp. It's simple and fast. The iLimb has 5 motors, rigid fingers, and up to 36 customizable grasps. The Australia Tasca hand is waterproof. It has 10 joints and rigid fingers. Finally, the Soft Hand Pro has 19 degrees of freedom, soft fingers, and endless grasp capabilities. In this framework, Soft Hand Pro stands up for its lightness and accessible market costs. These elements could generate a market demand and a relative positioning that is not covered by any other product at the moment. A new idea of affordable, high-technology prosthetic hand. In terms of final price for the market, Soft Hand Pro could be compared only with the MyoHand, that has the majority of the market in Italy, but is not comparable in terms of intrinsic technology. Moreover, Soft Hand Pro has unique features such as robustness and soft and deformable fingers. Looking at all these hands, I started to reflect about the hand finishing and covering, in terms of colors, shape, materials, human likeness, and so on. And I started looking for literature that could support my research, in structuring a framework to discuss the aesthetic and hermeneutic issues subtended in prosthetics design from a design discipline point of view. I didn't find any research on the topic, but I found interesting stimuli in the field of biomedical engineering and rehabilitation. Preliminary research was conducted on available studies, focusing in particular on the relation between users and their prostheses and their social interactions. Main issues emerged are associated with prosthesis acceptance or abandonment, prosthesis rejection rate, and psychosocial well-being. Users also describe an external shame and use the prosthesis as a defensive behavior to conceal their amputation. As such, they consider prosthesis as an important help to manage social interactions and restore the body image in a cosmetically acceptable way. And these issues are confirmed in anthropology and sociology literature, where disability is often perceived as a concrete form of otherness. The disabled people perceive themselves as something else, mutilated in relation to a normal standard. The stereotype content model elicits this idea. In this diagram are represented 2 elements: the idea of competence perceived and the sensation of warmth. The disabled people group elicits traditionally disrespect for a perceived lack of competence and pity due to the presence of some kind of warmth. But what happens if some robotic prostheses influence this schematization, increasing the competence perceived and decreasing the warmth? Bertolt Meyer studied this phenomenon and started talking about a new idea of evil cyborgs, a negative one. Well, all these reflections underline and confirm how disability can be understood as a cultural issue, able to increase or decrease social inclusion, favor stereotypes, and stigma. Moreover, in the design community, it's traditionally welcome the idea that objects have their own life, in the sense that they reinforce social practices just as social practices reinforce them, quoting Molotov. Also, Miller rightly argues that while we shape things, things are shaping us. These ideas let emerge and assume the consolidated bidirectional relation between individuals and objects, tool, prosthesis included. But there are not only bad examples. Worldwide, more and more often, it's possible to see different prostheses that looks at superheroes made out of Lego or objects that embody girls' fantasy as a glitter gun or decorative carters. But how is it possible to frame a state of the art to manage social acceptance and social sustainability? Pallin, from a design discipline point of view, point out two main design approaches, the realistic and the functional one. The first is defined through the focus on human likeness, through the use of materials such as PVC and silicone and colors similar to the human skin. The second, the functional one, and has its priority in functionality beyond appearance. The state of the art in upper limb prosthetic design can be so divided in two different approaches. One oriented toward a mimetic human-like design and another one that tends toward a non-mimetic design. It's possible to intend these tensions as opposing, as a dichotomy, as an issue that could be also managed by the design discipline. But also studies coming from other disciplines contribute in defining the state of the art. Mori, in the 70s, proposed a model of relation between human likeness and people's comfort level. In general, more human-looking artifacts are perceived as more agreeable, but this trend interrupts until testers experience artifacts that look so similar to humans that make them appear eerie, creepy. As possible to see, he considered also prosthetic hands. Other researchers have deepened the uncanny valley phenomenon, studying prosthetic hands. This paper led to emerge that passive human-like cosmetic prostheses cause a non-familiar feeling and eeriness, more than mechanical hands without any mimetic covering. Once identified this sort of dichotomy, diverse questions raised, such as, it's possible to search a mimetic versus non-mimetic dichotomy solution able to create acceptance and satisfaction in upper limb prosthetic users, comfort in social interaction, and a society culture able to favor social integration? How can the designer's role be exploited to favor cultural change toward a positive social acceptance of robotic prosthesis? To argument these questions, to highlight which could be the designer's role within the engineer's design team, were collected some design discipline pillars, highlighting how the design act has two main elements, the more tangible and the one that is intangible. Both engineers and designers act on the tangible aspects of a product, designing its materic and formal elements. While engineers work on the function, on the science, designers dispose of specific tools to manage the significant potential of materials, quoting Grioli. Designers also act through material aspects of the project, managing and redirecting perceptions toward aesthetic values that contributes in qualifying a positive product culture. As we can see, in the design community, this project dualism has been often identified and theorized. For example, about signifier and meaning, Vanon affirmed that a sign doesn't refer manifestly only to itself, but it constitutes an emotion forecast. In conclusion, to exemplify the role that designers could embody in a design process of robotic hands, to improve social sustainability in terms of social acceptance, I would like to briefly show what kind of design discipline tools we are using at Italian Institute of Technology. A sort of preview of next publication. For the soft and pro finishing are currently investigated two different product concepts. One that looks at the mimetic prosthesis finishing design and a meta-mimetic one. This second one starts from the idea not to hide an upper limb loss, but to be inspired by technology. To define this finishing design, engineers and designers are currently conducting experiments to define some design guidelines. Testing activities are made to perform better grasping, applying an empirical ergonomic approach to ameliorate also usability. Experiments, empirical for sure, studied 30 different objects grasps using moldable materials and chalk to study grasp dynamics. In the very conclusion, to increase social sustainability and deepen the aesthetic perception of prosthesis in society, we developed also a quali-quantitative survey composed of prosthesis images, so only the visual stimuli, related to questions about feelings and emotions, coming from the uncanny valley model and the stereotype content model. Thank you. Here you can find our contact.